Hello, everyone. I'm Sandor. I work here in Amsterdam for a company called Container Solutions. We do consultancy for cloud infrastructures, helping companies with Docker and other shiny new toys. And I was recently talking with Dennis about and trying to show him all this good stuff that we're working with. And it turned out that a lot of JavaScript developers actually never touch this stuff because it's very operations for them. So that's the time when the idea came up to actually do a Docker 101 kind of talk and show you guys why Docker is good and why Docker is good also for you. Because of course few words about me before I skip that. I'm a Java developer. No stone thrown, okay, great. I turned to doing infrastructure about a year ago because I found out that now these days it's getting quite interesting. And recently I did quite a lot of putting Node.js applications into production with the help of Docker. So Docker is a tool to package applications and run them in really nice ways in production. But it's also a tool that helps you with development, because the guys who made Docker, they package together all kinds of Linux kernel features to make a very nice product that can run your applications, and they really cared about the developer experience. And because of this, Docker became a tool that can bridge the gap between operations and developers. So it actually provides benefits for you as a developer. It's not just an extra you have to do for after your application seems to be working and you want to push it to production, but it actually can make your life easier. So why do we like Docker? First of all, it's a very nice way to package applications. It's kind of like a who doesn't know what Docker is here? I hope there is lots of people there. Can you raise hands? Okay, not that many. So I'll skip the really basic stuff, but you can think of Docker as a tiny VM that can start up under less than a second for your development purposes. It's a Linux process that thinks that it's running all alone inside a virtual machine, or in a machine, because it doesn't know it's virtual. So there is a great development experience that I will be showcasing. And because you are able to effortlessly use a virtual machine, you can prevent the production development drift when things on production work slightly differently than in your machine, and that causes really weird problems, sometimes very rarely, but then when they do come these problems, then they bite a lot and are always coming at the worst time. So this will be a very hands-on talk, practically no slides. I'll be just showing the development workflow of Docker. Let's start. So first thing I'm going to do, I'm going to go into my application, and the first thing I'm doing is not even my application. I'm just going to run a Docker container. And that container is going to be the official Node.js 8.0 container. And I'm going to run a command inside that container, which will be node npm version. So what happened there? Looks like nothing fancy at all. That's a bit of my problem with this talk, because it really doesn't look fancy. But what happened there, a completely new, clean, isolated environment has spun up, run that single command, and got destroyed. All under a second. So I could run ls inside this container and see that there is a real Linux file system inside. I can do make dir and then run ls again. As you can see, there is no directory inside, because these containers get immediately destroyed after the main process exits. It's also, one of the benefits is that you no longer are packaging virtual machines which contain all kinds of stuff, but you're packaging your one application that you need to deliver. That's actually pretty beneficial later on in the development process. So let's do one final basic thing. We can bash into the container. For that, we also need to enable console input. Somebody's calling me, not picking up right now. And here we are. We are inside the container. It's a real Linux environment. You can do pretty much whatever you do in Linux. I am on a Mac, so actually there is an application produced by Docker that pretends that I'm running on Linux. There is a piece of extra virtualization in there, but they made a really good job of hiding that fact. So you pretty much get the same experience as if you were running this on Linux. Because of Docker containers use features of the Linux kernel to achieve this, they have to be, they can only run on Linux. And nowadays on Windows also, but that's another story. So let's stick with the simple version for now. Yeah, so I can do the npm version or whatever I want here, or I can do actually the make dir, and now the directory actually exists there. By the way, is the font large enough? Is it good? I can, yeah? Okay, I see people nodding in the back, so I take that as a yes. Yeah, and I exit, and that container is gone forever. This actually is a weird thing for first-time Docker users, because they expect their virtual machines to live on and on and on. But actually, it's a very, very nice thing, because whenever you will start up your application again, it's going to be a pristine, clear environment. Now, I have a small Express.js app here, just the basic generated thing. I have a package JSON, just the most basic stuff. So how do I run this inside Docker? First, I will create, in my IDE, I'll create a Docker file. The Docker file will tell Docker how to execute, how to build a new image from my application. The standard is to call it a Docker file, and actually I want to move it out of here into the root. So as you can see here, my package JSON is outside of the application, because I want to separate the node modules from the actual application files, because I will never have the node modules on my laptop. It's a choice. It has benefits to have them there. I'll show later, but it's the way it works best for me. So inside this Docker file, I write commands. My first command will be from node 8.0, meaning I'm extending the node 8.0 container. What happens there is there is a bunch of commands in another Docker file that describe how to build the basic Node.js container, and I can extend this image to add a few things I need. And I only need a few things. I just need my application to be in there, maybe install some libraries and whatnot. So this is another great feature of Docker, that you can build on top of golden images and do this in a nice controlled way. You don't have to install Node.js and play around with that. And also, because Docker is very popular, there are official images to use. So if you're worried about somebody pushing some image into the Docker hub where we are pulling the images from, you don't have to. There are official images for most major technologies, including databases and so. So I will extend the Node 8 container, and I will copy my package.json in there. Oh, first I will set my work directory inside the container, and I will call it approot. And I'll copy package.json into approot. And then I will execute npm install. So why am I doing this in this weird way? Why not just copy everything into the container? It's a little trick. If you're working with Node.js and you'll try Docker, this is one of the first things you need to learn about Docker is the caching. Every command here that actually does something to the file system, Docker will decide whether Docker will create a separate layer so it can be cached. And so the effect of the whole thing, I'm not going into details, but the effect will be, unless package.json actually changes, npm install will not be executed over and over again. Now, I cannot demonstrate it, unfortunately, because the npm install on this Wi-Fi would take too long time. So I will be doing some tricks here to actually make this work. But this is how you do it. And then I copy the app directory inside approot/app, or to approot/app. And that's it. That's how I would normally build mine. Now I would run docker build, tag the image, say my app, and run it in this directory. I will not do that now because that would fry the Wi-Fi. What I will do is I actually did this exact same thing in another container that I produced for before, which is called my app base. And building on top of that, that already contains the package JSON and already has the npm install run. So my container will just be extending that with my actual application. Now I can build this without crashing the Wi-Fi. So I have a container called my app. I can list the local images. Another confusing thing for people usually about Docker is containers are running processes. Images are the things that contain the files, and the commands to actually spin up. Another important thing is when I write npm install here, this happens during the build time. So basically, it will produce an image that contains the files that npm install produced. It will not run npm install when I just start up the container. So here are all kinds of my app images. This is the one I just built. It's 767 megabytes actually, because it does contain actually a full Debian Linux with Node.js and everything it needs installed. But because of the layer caching, you can work with this stuff very efficiently, even when you're pushing that stuff to production. All the base images that you are building on can already be in production, and the Docker will be smart enough to figure that out and only push the stuff that you're adding. Yeah, sorry, I just see how I'm doing with the time. Good. Yeah, so now that I have my image, I can run it. Again, Docker run, my app, and I'll need to do a few things. First of all, I need to specify an environment variable called debug, app, this, whatever. You guys know more about that than I do. But this is to see the debug output. You can see I can specify environment variables for the environment where the container will run. This is again something you don't need to modify your own laptop to run an application. Everything goes on the command line to this to Docker. Another thing, if I now start up the application, let's just try that. So pm start. Whoops. It's the best thing that can happen on a live demo. Oh yeah, I didn't specify which container, or like I specified things in the wrong order. Yeah, this is the name of, first go the parameters, then go the name of the container. Yep, and it's running and listening on port 3000. But not port 3000 of my laptop, but port 3000 of the virtual network that's created by Docker for the containers. So even the network is isolated. So what I need to do to actually access this container, I will also add the TI parameters, because that makes Control-C actually work. Fortunately, it somehow works because of npm too, but so I need to expose port 3000 from the container to port 3000 on my laptop, or I could choose whatever else on my laptop, but let's just keep it simple. Yep, and now this should work. Beautiful. Yeah, you can see I'm a Java developer, right? CSS is not really my thing, or fancy web applications. So yeah, we have an application running in an isolated environment. We can kill it, recreate it, etc. without, yeah, I don't even have npm installed on my laptop. I don't need it because everything is inside the container. So, but I want to have the proper, so now if I change anything in the application, I need to build the image again and then run it. That's not what JavaScript developers are used to. you want to be able to change files and have something like nodemon pick up the changes and rebuild the application instantly. So what I can do, instead of constantly rebuilding the image, I can mount my app directory into, as a volume mount. I can mount it, doesn't understand what's the current directory for some reason, so actually I have to run pwd, and I mount it into app root/app. The files are already copied into that container, but a volume mount will just override them as if they were not there. So, yeah, cannot find module approot app bin www. That's not good. Approot/app. Okay, so I'll show you some Docker debugging magic. Let's bash into this container and see what we have here. Actually, we have everything in the right place, the app, the node modules, and the package.json. So let's exit from there and see what could be wrong. So my app, the copying worked, so that's okay. Package.json, everything should be right. So that, oh yeah, I'm not mounting /app. Oh, and now I must run actually npm start. Yep, there we go. And let's try to change something. Let's go to routes, Amsterdam.js. Okay. Oh yeah, I need to actually run nodemon. Yes, not npm start. So nodemon is something I need to install into that container. It's already installed in my base image. Otherwise, my original way to do this was to modify the Docker image at this point, adding another run command to install nodemon. So that's already there. So yeah, now it should be changing. Yeah. So the point of this is, it's very simple, but showing that you can have the full, like, normal development experience. Docker doesn't take anything away from you. So let's see another nice thing about Docker. You are no longer, so npm manages your dependencies very nicely, that's all good. But with Docker, you are actually in full control of the whole operating system level stuff also. So what happens usually when you want to do graphics manipulation with image magic or graphics magic, right? You have to install that on your laptop first, and then when you actually ship the application to production, you have to make sure that it's also on that machine and also on your colleague's machine, and that's the right version. And that's a lot of hassle. So with Docker, you can actually create a package that contains all the binaries too. So let's see. Of course, I already installed graphics magic to that base image. Let me show you how the base image Docker file looks like. So you can see here I'm installing nodemon into it, and here I'm doing apt-get update and then apt-get install graphics magic. You can see that the Linuxy stuff is really creeping in here. This I'm using apt-get because it's a Debian image. So actually how I would like to see Docker is something like npm, just a package manager where I'm just specifying things, but that's not how it works. This makes it very versatile and very reusing existing skills and everything ways how we do things. That's the upside. The downside is that you have to remember that you have to do apt-get update before you do the install and that kind of stuff. So this is already installed in my image. And now I'm going to create a new route and do some image manipulation stuff inside the application. I'm just gonna copy paste this over here. So what this will do, I will strip it down to what we actually need here. This will load an image, resize it, and stream it to the browser. Actually, 90% of the preparation for this talk was spent on debugging graphics magic, so I'm very proud it's working now. Not because it's so hard, but because it just doesn't give you any error messages for some reason. So you just have to keep guessing. So yeah, let's rebuild our image. With so actually, I didn't even have to do that because now it's running with NodeMon. Yeah, and oh yeah, I have to add it to the path is here. Image and oh yeah, and here. Ouch. Not found app.js. Sorry? Ah, yeah. Thanks, dude. It's first ever time I'm doing a live demo, so yeah, that's missing some things here. Now, okay. Yeah, you can see I can change the width of the image, maybe not to 10,000, and it's working. This is a really cool guy. I like him. You might have noticed I like Doom a lot. Yeah, he's called the Revenant. So you can see graphics magic is working, even though I also don't have that installed on my laptop. And now if I deliver this package to my operations team, they don't have to do anything about it. They don't even have to know graphics magic is there. Also to my colleagues who want to work with this, nobody has to ever again write that piece of documentation that says, please install graphics magic. Now the next thing is running several containers. These days, many people do microservice architectures. It's such a hassle to start up everything on your laptop and even care about the installing the right version of everything. So Docker has a tool called Docker Compose, which I will add to the application now. Docker Compose is used for running several services together, or just one and avoid typing everything on the command line. So you can see that I have two services here, the My App and the Words database. My App, I specify everything that we specified on the command line before, except I think I have to modify this to app root. Yeah, the rest is the same. And the Words DB will be a standard MongoDB image. You can see that this My App will be built from the current directory, so that's like a live thing that must be rebuilt. But Words DB is something that I just pull from the repository. I don't have to do anything about it. And it will start up MongoDB. It will map port 27017 if I want to look into the database. But actually, I don't want to do that, so I can just get rid of this. And I will suppress logging, and this volume stuff I will remove for now. I will suppress logging because MongoDB is really chatty. So, and the nice thing here is, if you look at my database manipulation code, please don't laugh. I'm not a Node.js expert, but it's not that bad, I think. So you can see here my connection string. You can see that the host name here is wordsdb 27017. It means Docker will actually create a virtual network where this will be an actual working host name. So I no longer have to worry about if I'm running two databases or two applications that the ports will clash. I could run any number of MongoDB databases with different host names on the same port. So the whole networking stuff also feels more real. So what I can do now is do Docker Compose up. And let's see the next error. Oh, look at that. Seems to be working. Okay, so yeah, what this application is actually doing, it keeps a database of words that it will produce a random words out of those. Yeah, I'm not very creative on this stuff. So I will use curl to push my word. I just do 1, 2, 3. Okay. Yeah, I need the words controller actually. That's not good. /word or /words. Okay, let's see the logs. Cannot find module ... database. Yep, because it needs to be inside the application. That should be better. Yep. 1, 2, 3. How do you spell 3? Not like that, right? Now I'm getting back. It's always 3. Oh, look at that. My random number generator works. Perfect. So you can see the application communicated with the database, stored some data in the database. And now if I quit and do Docker compose up again, what will happen is, why do I have words there? Holy shit. That's cool. Okay, it's not running, is it? Okay. Ah, that's it. No. Even 4. Okay, that's really weird. And I won't figure it out now, why is that happening? Well, how until now I thought Docker works is that the database gets destroyed. And to, sorry? Sorry? Yeah, well, that's what I wanted to show was actually if you add the volume to the database to store the files in your computer then, or on your file system, then you will get the files there after a restart. So and probably Docker Compose does something with the database. So yeah, nope, yeah, okay, I'm done, don't worry. That's actually all I want to show. I combined the words with the image magic, but actually that doesn't add anything to the whole demo. So I will rather have some time for questions. But first, to summarize, Docker is fast becoming the standard way to packaging applications. You, as a front-end, back-end developer, should use it because, on one hand, it really helps you with producing stable and reliable development environments. And then, actually, an added plus is whatever you build here, you can just grab and ship it to production without any hassle later. Yeah, that's the message.